This video is about the principle of mathematical induction. Here is the definition. Let P sub n be a statement about natural number n. Then P of n is true for all natural number n, if and only if P sub 1 is true for every natural number k. If P sub k is true, then P sub k plus 1 is true. If you want to use the principle of mathematical induction to prove, first step, make sure the statement is true for n equals 1. Second step, assume the statement is true for n equals k. Then you prove the statement is true for n equals k plus 1. Then the statement is true for all natural number n. We use cap to do the math induction proof. When we are dealing with the summation statement, here's the step. Very beginning, figure out a sub k plus 1. Then figure out s sub k plus 1. Then use cap, check n equals 1 true. Assume n equals k true. Last step, prove n equals k plus 1 true. Therefore, the statement is true for all natural numbers. Let's go to some examples. For number 3, we could say this is a summation statement. First step, we work out a sub k plus 1. This will be a sub n. And this will be s sub n. Every single n you turn into k plus 1. So we got the 2 to the k plus 1's power. For s sub k plus 1, you will get 2 times 2 k plus 1 minus 1. First step, check n equals 1 true. On the left side, we got the 2 to the first power. On the right side, we got the 2 times 2 to the first power equals 1. This is true. Second step, assume n equals k true, which means 2 plus 2 squared plus 2 to the k's power equals 2. 2 to the k's power minus 1. In other words, you just need to rewrite everything for the statement, change every single n into k. Now we want to prove n equals k plus 1 true, based on n equals k true. Therefore, on the left side, when n equals k plus 1, we will get the 2 to the first power plus 2 squared plus 2 to the k's power plus a sub k plus 1. Then next step, just a plug-in game. This is a given from second step. Plug this in. So we get 2 times 2k minus 1. For a sub k plus 1, we already figured out very beginning. Therefore, you need to plug in 2 to the k plus 1. You need to prove these expressions equals s sub k plus 1 equals this. Then you finish proving. So you need to know your goal. You want to prove this expression equals here. So we do distributive property first. You get the 2 k plus 1 minus 2 plus 2 times k plus 1. Then I combine like terms. you will get the 2 times 2 to the k plus 1's power, and then minus 2. Since we have 2 over here, therefore I take a 2 outside. I got the 2 to the k plus 1's power minus 1. Then we finish proving. And you could see the statement is true for all natural numbers n. Let's go over the steps. First step, you will figure out a sub k plus 1 and s sub k plus 1. Then for step 1, step 2, kind of like easy for you to get. For number 3, basically you are proving a sub 1 plus a sub 2 plus a sub k plus a sub k plus 1 equals to s sub k plus 1. For number 5, a sub k plus 1 equals 3 times k plus 1 minus 2. You will get 3k plus 1. S sub k plus 1. We always assume this is a sub n, this is s sub n. You will get k plus 1 times 3 times k plus 1 minus 1, then over 2. You organize, you got the k plus 1 times 3k plus 2 over 2. So first step, check n equals 1, true. That's on the left side, we have 1 equals 1 times 3 times 1 minus 1 over 2. This is true. Second step, we assume n equals k, true. Therefore, we got 1 plus 4 plus 7 plus, change every single n into k, so 3k minus 2 equals k times 3k minus 1 over 2. Step 3, prove n equals k plus 1 true. Therefore, we get 1 plus 4 plus 7 plus 3k minus 2, then plus a sub k plus 1. You could say using this, just add a sub k plus 1. Then next step, just a plug-in game. We got this part equals this. And a sub k plus 1 equals 3k plus 1. So we get the k times 3k minus 1 over 2 plus 3k plus 1. We'll organize this expression. Try to make it equals s sub k plus 1, which means this one. First of all, I will make a same denominator. So multiply by 2 top and bottom. Then we organize. We do distributive property. 3k squared minus k plus 6k plus 2. Therefore, you will get the 3k squared plus 5k plus 2. Then you can do Ninja X this time. You will get 6, here's 5, over 3 over 3. So 2, 3, 1, 1. Then we put the k here. Factor that. We got k plus 1 and 3k plus 2 over 2. So we finish proving. Therefore, the statement is true for all natural numbers. For number 7, assume this is a sub n and add n here. So we get the a sub k plus 1 equals 2 times k plus 1 minus 1, then you do square. Just change every single n into k plus 1. So we get the 2k plus 1 square. For s sub k plus 1, you could say every single n turn into k plus 1. So we get the 2 times k plus 1 minus 1. Then times 2 times k plus 1 plus 1 over 3. Then you organize. You will get the k plus 1 times 2k plus 1 times 2k plus 3. Then first step, check n equals 1 is true. So on the left side, we got the 1 square. Is it equal to 1 times 2 times 1 minus 1 times 2 times 1 plus 1 over 3, both equal to 1. That means the statement is true when n equals 1. Now assume n equals k, the statement is true. So we get the 1 square plus 3 square plus 2k minus 1 square equals k times 2k minus 1 times 2k plus 1 over 3. For second step, you just need to change every single n into k for the statement. Then we need to prove n equals k plus 1 true. Therefore, I just bring down this one, then add a sub k plus 1. So we get the 1 square plus 3 square plus 2k minus 1 square, then plus a sub k plus 1. Then just do the substitution now. For this one equals here. This one equals here. So we get 3k times 2k minus 1 times 2k plus 1 plus 2k plus 1 square. Then you need to organize these expressions. Make answer equals s sub k plus 1, which means this one. First step, we will make a same denominator. So multiply by 3 to the numerator and the denominator first. Then put the numerator together. I have k times 2k minus 1, 2k plus 1, plus 3, 2k plus 1 square. To the top, I will take a 2k plus 1 outside. Because that's the common factor, is a 2k plus 1. You will get the k times 2k minus 1 plus 3 times 2k plus 1 over 3. Then we simplify. You will get the 2k squared minus k plus 6k plus 3. Therefore, we still have 2k plus 1. For this part, we got the 2k squared plus 5k plus 3. Then we got to do ninja x. 6 over 2 over 2. 5. So 2, 3, 1, 1. We put the k. Therefore, we will get 2k plus 1 times k plus 1 times 2k plus 3. Then you compare this one to this s sub k plus 1. You could see they exactly the same. Therefore, we finish proving. You can write down the statement is true for all natural numbers. For number 9, we know this is a sub n. This one means s sub n. So we get the a sub k plus 1. Every single n changing into k plus 1, we got 1 over k plus 1. For s sub k plus 1, you will get 1 minus 1 over 2 to the k plus 1's power. First step, check n equals 1 is true. On the left side, we got the 1 over 2. On the right side, that's 1 minus 1 over 2 to the first power. This statement is true. Second step, assume n equals k true, which means 1/2 plus 1 over 2 squared plus. Just rewrite the statement, change every single n into k. 1 over 2 to the k's power equals 1 minus 1 over 2 to the k's power. For number 3, prove n equals k plus 1 true. So we rewrite this one and add a sub k plus 1. We get 1 over 2 plus 1 over 2 squared plus 1 over 2 to the k's power plus a sub k plus 1. Then just a plug-in game. See, this is the one equals this. This one equals this. 1 minus 1 over 2 to the k's power plus a sub k plus 1, that's 1 over 2 to the k plus 1's power. Then we need to organize these expressions, make the answer equals this. We have 1 over here, so this one don't do any change. This part is 2 to the k plus 1. We already have 1 over 2 to the k plus 1. Therefore, you need to make 2 to the k's power into 2 to the k plus 1's power. So we multiply by 2, top and bottom. You will get 1 minus 2 to the k plus 1's power 2 plus 1 over 2 to the k plus 1. Then you need to combine like terms. We can put the parentheses. Here's a minus. Then change this one into minus. Then combine like terms. You will get 1 minus 1 over 2 to the k plus 1's power. Then we finish proving. Last step, write down the statement is true for all natural numbers now.